This video I'm going to work out a good handful of problems. For these, this would be a time for you to try these on your own first. So I would encourage you to try problem 1 and then watch the video maybe for problem 1, check your work, do problem 2, check your video, your work with the video. Or you could try the whole thing if you would like. I typically stray away from that because if you do the whole thing and you miss it, all of them, then you get to go back and do all of them again. Instead of maybe you did one, missed it, checked it, fixed your understanding. Either way is fine. It just depends on what you prefer. Okay, so good rule of thumb always is change things to sines and cosines. I'm going to show you a method that I don't think I knew as a student, but it has helped me tremendously as I've done more and more of these. Okay, so what we're going to do here, I'm going to change them all to sines and cosines. All right, so cosecant is 1 over sine minus, and I'm going to go ahead and put sine theta over 1 just because it feels better here. And then cosecant on the bottom is going to be 1 over sine. Okay, what I notice here is all my denominators are either a 1 or a sine. So I could easily get rid of every fraction if I can multiply things by sine. So I'm going to do that, and I'm going to do it on top and bottom. So I'm going to multiply the top by sine theta, and then the bottom by sine theta. The reason I'm allowed to do this is because what I'm multiplying by here in red is actually just 1. So I didn't change the expression at all. I'm just introducing a form of 1. So this red, the sine goes here, and it goes there, and this one's going to distribute there. So we get, okay, sine times 1 over sine is 1. Minus sine times sine is sine squared, theta. Notice we're writing thetas on every sine. I'm not getting lazy and forgetting them. 1 over sine times sine is 1. Okay, and then I can say, hey, I know what that is. 1 minus sine squared is cosine squared. So we changed that nasty expression there to just a cosine squared. Okay, on the number 2, notice that it's already in sines and cosines, but I see that 1 plus cosine on the bottom, and this indicates to me that I want to use something probably close to the conjugate, and notation-wise or definition-wise of that word, I'm not sure if the 1 minus cosine is considered a conjugate of that, but it mirrors that same idea back in PreCalc 1 when you would have like the square root of 2 plus 1, and you would need to multiply by the conjugate, or forgive me, let's do it this way. 1 minus the square root of 2, and I would need to multiply the conjugate, so I would do 1 plus the square root of 2. It's that same idea, so that's why I call it the conjugate, but what we're really doing is manipulating to match an identity. So, oops. Give me. Okay, I'll just leave that over there. All right, so I'm going to multiply top and bottom by 1 minus cosine theta. So 1 minus cosine theta. And I'm multiplying by 1, so that's what keeps me legal there. On top, I'm going to get a sine squared theta. I'm not going to distribute till I know I need to. Notice we're writing our thetas every time. And then on the bottom, what's going to happen is that's the difference of squares. And that's going to where the middle terms are going to cancel out. So I'm just going to square 1 time, or do 1 times 1, and then do minus cosine times cosine is cosine squared. All right, and that actually fixes something for us. The bottom is going to be the same as sine squared theta. The top, I didn't multiply it, and this is the reason I didn't multiply it, because typically when you multiply by the conjugate, this is what happens. Those sine squareds go away. And this just leaves me with 1 minus cosine theta. So that's what we have there. All right. Simplifies it quite a bit. All right, let's look at problem 3 here. So maybe you don't see it, but the cosecant squared minus 1 is a Pythagorean identity. So I'm going to show you how to get to it in case you're wondering. So I would do sine squared plus cosine squared. Notice I'm writing my thetas equals 1. And I'm going to go ahead, I need a cosecant, so I'm going to divide by sine squared. But if I do it there, because of equations, I got to do it everywhere. So I'm going to divide every term. That gives me 1 plus cosine over sine is cotangent. And 1 over sine is cosecant. So I can now see that if I minus these 1 over, I get cosecant squared theta minus 1 equals cotangent. So I'm going to change the top to a cotangent squared. All right, then I got cosecant squared theta on the bottom. And now I'm going to use the division stuff we were doing earlier. I'm going to go ahead and change the cotangent and cosecant. Cotangent is cosine squared theta. Notice we're writing our thetas everywhere. Cosine squared over sine squared theta. And I'm going to divide it by, okay, cosecant is 1 over sine squared theta. Okay, now I keep the first term, and I'm going to go ahead and multiply and flip the second. So it becomes sine squared, oh, forgive me, I started flipping it because I was saying flipping. Cosine squared theta over sine squared theta multiplies by sine squared theta over 1. The sine squareds are going to cancel, and this just leaves me with cosine squared theta. All right. So there's a trick there with the identity. I guess it's not a new trick. I erased a lot of things on this worksheet I stole, and they're popping back up. Okay, so blue, middle one. Perfect. Okay, so let's do one more here in this section, and then we'll start verifying some identities. So we're going to take tangent, secant, and sine and change them to sine theta over cosine times secant is 1 over cosine theta. And then sine, I'm going to change it to sine theta over 1. All right, so notice nothing cancels, but I get sine squared theta over cosine squared theta. And that's going to leave me with a tangent squared theta. All right, we have a handful more. We're going to work on our identities for, I think, 8. I have 8 problems. I want to give you plenty of examples because just to warn you, these are hard. Most people, this is the most dreaded topic in this class. For people that have taken it before, they usually groan once I mention something about an identity. So my thought is, if I can show you a bunch, I'm going to give you so many to use in your quote-unquote toolbox that you can use to get through these problems. Okay, number 5 is just going to be changing to sines and cosines. So tangent is sine theta over cosine theta. Cosecant is 1 over sine theta. And then cosine just is a cosine theta over 1. Remember, I can't move things across the equal sign. That's why I'm working only on one side, and I'm trying to match the other side without moving things across the equal sign. Okay, I can see that this cosine and that cosine will cancel, and that sine will cancel, leaving me with a 1, and that equals. Okay, one thing I want to point out, when you guys are doing these and you're going to be turning them in for me, like on a test, I have several students that end up taking this away and being like, well, I can see that's going to be a 1. That's not how this works. You have to show me that you understand the content. All right, so you have to show me that left side, that one step. I'm not even asking you to put them together, a sine, cosine over sine, cosine. You can show me that you at least know each one of those and they mark out. You cannot skip steps because you're showing proof. There are very little, like that last step, you could skip that because you showed me the understanding within why things are canceling. All right, so if you're unsure, like, yeah, that doesn't feel like a secure answer for me, don't skip steps, all right? Okay, so number 6, we're trying to show that left side equals the right side. So let's multiply. I can see that these are a difference of squares. Notice they're the same thing, but one's plus, one minus. So that means the middle terms are going to cancel out. So all I need to do is multiply this and that and call it good. Sine times sine is sine squared theta. And then we're going to have minus cosine squared theta. And we're still trying to match this side, so I need to get things in terms of cosine. So I'm going to replace my sine squared here with a 1 minus cosine squared theta minus cosine squared. I only used parentheses here to show you that this sine squared theta is the exact same thing as that 1 minus cosine squared. Okay, I take this one more step further. I have 2 of those, and they're minus, so I get negative 2 of them. And that's the right side. So notice I wrote all my thetas. I didn't write anything like this. Please do not. I will count off. You have to write your thetas, and notice also I showed every step. Have to show your steps. Okay, number 7. They got this one started for me, so we'll use it. Usually they would cover this up. That's what they would want you to prove. But we're going to start by, I see the 1 plus cosine, and I would start by multiplying both top and bottom by 1 minus cosine. So I got sine theta times 1 minus cosine theta. Okay, and remember I'm trying to match. Okay, the bottom, the reason we do this is going to end up 1 minus cosine squared theta. The middle terms are going to cancel out. Notice I'm showing all my steps. Okay, the next line, I'm not going to multiply the top out, and this is the reason. Right, that stays the same. The bottom, though, is an identity. Right, it's equal to sine squared theta. Notice one of those will cancel with one of these, leaving me with 1 minus cosine theta all over sine theta. And we have proven it. We have matched. So notice a couple things to note. I wrote the theta every time. I know I'm mentioning it a lot, but that's my biggest thing on tests is people start missing that, and I count off quite a bit for it. So make sure you're writing your thetas or x's or whatever we're talking about there. And then the second thing I noticed, I showed every bit of it. Every step was shown. And then notice that we started with the conjugate. So take a note what this problem looks like. And if you need to get from one side or the other of this original equation, remember we multiply by our conjugate. All right, the next one, I see a sine squared, and I see that cotangent. I'm not sure how to start, so the first thing I'm going to do is change things to sines and cosines, and I'm going to start with the left side. So I get sine squared theta times 1 plus, that's going to be cosine squared theta over sine squared theta. Now I'm going to distribute. It goes to both, right? So I get sine squared theta plus the sines are going to cancel in the second multiplication, leaving me with a cosine squared theta. And then right away, I hope this is the only one you really have to memorize. That's equal to 1. Notice I wrote all my thetas. Okay? So anytime I see extra cotangents or anything like that, I'm like, okay, if I'm unsure what to do, I change them to sines and cosines and just see what happens. Most of the time when I'm doing these problems, I don't know where I'm going to begin with. I just take off in a direction. And half the time it works out and half the time it doesn't. But you can just retrack and try something else. But try to change if you're unsure, and you can change things to sines and cosines. Do it. All right, we're going to make these a little more complicated. Check out number 9. So what I'm going to do right now, because I see that minus, I can't treat this like the other things we've done where we can multiply by things yet, but maybe I see a secant, cosine, maybe I can change them. Okay, so secant on top is going to be 1 over cosine theta minus, I'm going to go ahead and put cosine theta over 1. And then on the bottom, I know secant is 1 over cosine theta. All right, so that's what I have there. And this is from previously, what we've done before. I can get rid of, notice the only thing in the denominator is a cosine. So I'm going to multiply by cosine theta over cosine theta. I do it on top and bottom because when I multiply by that, nothing changes. It's still 1, multiplying by 1. So this goes to both here and there. The first one gets me a 1, and then I get a minus cosine squared theta. And then on the bottom, notice that it just goes cosine over cosine, which is going to be a 1. 1 minus cosine squared, we know that one by now. That's sine squared theta, and it's equal to the right side. Notice I'm writing the theta every time. Okay, number 10. Things are being multiplied, so I don't really have to go through the route I did in number 9. I can try just maybe putting them in sines and cosines, which is what we did in number 9, but I think things will probably cancel out. Okay, so let's change them all. Cotangent is cosine theta over sine theta times, okay, secant is 1 over cosine theta. And then on the bottom, we have a cosecant. That's going to be the same as 1 over sine theta. Right, I can see I can do a couple things here. I'm like thinking I'm going to have to do some division. and I'm not going to need to, because what's going to happen in the numerator, this cosine cancels with that cosine, and I get 1 over sine theta divided by, and I'm not even going to make it even more complicated because we're going to see what it's going to be here. 1 over sine theta, and I know it doesn't look nice, but that's the same thing over itself, which means it has to be a 1. All right, I got 2 more. All right, number 11. Okay, I don't see anywhere to start, so the first thing I'm going to do, because I have tangents and secant, I'm going to change it all to sines and cosines. Okay, so this becomes 1 plus sine squared theta over cosine squared theta. All right, and it's a complex fraction, that's okay. We're probably going to multiply our way out of this. And then secant on the bottom is going to be 1 over cosine theta. So it makes sense, if I want to get rid of all my denominators, I think I should multiply the top and bottom by cosine theta squared. I do the top and bottom so I don't change the problem. All right, so this has got to go to the 1 and go to here. Cosine squared theta times 1 gets me cosine squared theta. The second multiplication here, the cosines are going to cancel, leaving me with the sine squared theta. And then this is going to be all over, okay, cosine squared times 1 over cosine is going to leave me with just a cosine. Hopefully you're like, okay, that I know what that numerator is going to be. It's 1. It's the one identity I ask you to memorize of the complicated ones. Leave me with a 1 over cosine, and that is secant. That's what we were aiming for. A couple things to note. That plus sign kind of led me to this kind of strategy. Notice also that I didn't have anything that looks like this. Right? I'm writing my thetas where they need to go. All right, let's try number 12. Okay, I'm going to multiply that out. Notice it's a difference of squares, meaning that they're the same thing. One's plus, one's minus. So I'm going to go ahead and multiply it. It's going to be 1, because 1 times 1, and then minus cosine squared theta. The middle terms would have canceled. Trying to get it to 1 over cosecant. I could even do this, because I don't really want to deal with the 1 over cosecant. I know that's actually sine squared. So I did work on both sides, and that's okay. I can work on both sides, but I can't move things over. And then this makes this even easier. 1 minus cosine squared theta is sine squared theta. We are done. These are going to take practice. These are difficult. I can see where I'm going next because of the years that I've put in learning these and teaching these. It's going to take time. Give yourself grace. Yeah, we'll do some more.